Welcome everyone, DPRG's monthly meeting for May here during our pandemic. We're doing it remotely again. And switch screens. I think all of us on the call know, but for those who are watching the recording, DPRG is all about those of us who like to learn and build things and program and sensors and motors and microcontrollers. We've been around since 1984, nonprofit organization. We meet every Tuesday night and second Saturday. And we want to give a shout out and thanks to our supporters, Mauser, Pololu, Rev Robotics, Vex Robotics, RoboRealm, Tiny LiDAR. These guys help us a lot and we appreciate it. Great sources. Today we'll have two parts. The first part will be, as our main presentation this month, something called Robots versus Humans, about internet search engines. And then for anybody interested, we can still, after that, have a open mic, open webcam, and show and tell what projects we've been working on. So robots versus humans. Where did this come from? You know, if we think back to Isaac Asimov, maybe even before that, but at least Isaac Asimov kind of influenced me when I was growing up, and kind of fun thinking about that. Or maybe, was it the 70s or 80s, Kit the Car, remember that? Robots. Or maybe we think of robots as what we do in a club typically. But today we're going to take a little detour from these more traditional robots for DPRG. Today we're going to talk about virtual software agents. So Wikipedia, Fountain of All Knowledge, has this definition that includes not just the physical robots that we do, but also that there are software kinds which can basically, they have to carry these characteristics. They might accept programming, process data, right? They operate autonomously, and they're able to sense and manipulate things in the environment. Which takes us to, if you look closely on this Isaac Asimov iRobot cover, man-like machines rule the world, right? Fascinating tales of a strange tomorrow. But we're here already, right? Because in a way, there's Tesla, right? And so we're about there. So today we're going to walk through things about internet search engine robots. Sometimes you'll see them just called bots. Talk about how they work, what they do, and then most of this is really geared towards website people that own websites and use these internet search engine robots. How they get the robots to do their bidding. I'll touch a lot on how the robots are constantly experimenting on us every time we search the internet. How they're gathering intelligence on us and how they're manipulating us at the behest of the website owners. We're going to talk a lot today about Google. It's the easiest big elephant in the room to go focus on and look at their tools, but keep in mind that the same principles apply to all these others, or Instagram or Snapchat or any of these other things which know your preferences and then provide things for you to see based on what they think about you. So we have kind of a small group. Feel free to interrupt if you like. But I just wanted to set the stage on what today's presentation is about, how it's a little different from the usual DPRG. So let's get diving in. So for this presentation, I'm just recycling something that I gave about a year ago. So to warm you up to what the presentation is about, you need to imagine you have a website and you want people to find your website and buy stuff from you, okay, on your website. So that's your goal. You want people to find you you want them to be on the internet and find you and buy your stuff, basically. And so you would have this question naturally, right? How can you maximize the number of people that visit your website, the traffic, and how many people actually buy? So you're the website owner and that's your goals. So one answer, how you could do that, there's this phrase you'll hear called search engine optimization, or sometimes people call it SEO. That's basically all about making these internet robots, these virtual software agents, making them work for you. Welcome, Mr. DPA. All right, so, and if you guys don't mind, I'm going to back up a little bit and repeat some of this just for Dave to set the stage. So we're going to back up. Dave, speak up if you can't hear me. So basically, Dave, the whole concept for today is robots versus humans about internet search engines, right? So robots versus humans. Think way back to Isaac Asimov, iRobot, maybe Kit the car in the 70s or 80s. Now we have Tesla, right? So the future is here. In DPRG, we tend to think about these traditional robots. Hey, Michael, welcome. So with DPRG, we tend to focus on these traditional robots, but for today's presentation, Ron Grant. Okay, now everybody's here. I'm going to back way up again. Okay, welcome, guys. We're going to repeat some stuff for you, but fly through it. But I think it's important to set the stage. So today we're going to talk about robots and humans versus humans, but it's really about internet search engines. If we have time and interest, then we'll have an open mic for show and tell. And just speak up or add to the chat if you can't see my screen. So robots versus humans. Why are we doing this today? Well, for one, couldn't find any presenters on the traditional style of robots. So people wanted to have this meeting, so I dug up this old presentation I gave, which I think is still relevant, and a lot of people find it interesting. So robots versus humans. So theme has been going on for a while, right? Think back to Metropolis, right? Or more recently, iRobot and Isaac Asimov. Or maybe was it the 70s or 80s? Kit the car, right? Well, here we are with Tesla, so it's getting close, isn't it? Or we have our DPRG style robots. And then if you go to Wikipedia, robots, not only physical, but virtual software agents, right? Because they have these characteristics. They accept programming, they process data, they operate autonomously, and they can sense and manipulate their environment, whether it's physical or virtual. And even back to Isaac Asimov times, right? Machines rule the world. Fascinating tales of a strange tomorrow. Well, here we are today. It's already upon us. So this presentation is about search engine robots. Sometimes you'll see them called bots in the media. It's about what they do, how they work. And it's really, this presentation is really geared towards, like, let's say you're a business owner and you have a website, and how would you use these? How would you rely on these things? So this presentation is all about how you guide or program these internet search engine robots. And I'll talk about how these robots are constantly experimenting on us, and how they're constantly gathering information on us, all with the express purpose to manipulate our behavior as humans, right? So nothing nefarious there at all. So we're going to talk today about Google, mainly because it's easy. They cover all the bases. But keep in mind that the same principles are going on with all these other names, or Instagram or Snapchat, or all these other machines out there that watch our behavior are doing similar things. So keep that in mind. So it'll help because this presentation, I dusted it off from when I did it at work about a year ago. But it'll help if you imagine that you have a website and you want people to find your website and you want people to buy stuff on your website, right? So that's the goal here. So how are you going to do that? Well, then your question might be, like, how can you maximize the visitors, the traffic to your website, and then how often they buy from your website? So that's what you're trying to do here. That's the goal. Your goal as a website owner. One answer, search engine optimization. You might have heard the term. Sometimes you'll see it called SEO. Bottom line is, it's all around things you can do to your website to make those internet search engine robots do your bidding and work for you. So that's what this presentation is about. And actually, we think of feedback loops as PID or Kalman filters, very technical things, but in other dimensions, I like to think of this at my job as we're closing the feedback loop from the search engine results that I can view as a website owner to the sales that I can measure in the cash box. And it was DIY because you can pay marketing agencies lots of dollars to do this, or you can do a lot yourself. And that was the crux of this presentation. It was geared for startups with no money, and how you can use free tools and very inexpensive tools to go make these internet search engines work for you. Briefly about my company, Telecom. We do phone service for families living with Alzheimer's and other dementias. So all of my examples are coming straight from this company, plus whatever meetups and study that I did offline. And we'll share them afterwards if you find them interesting. And I was using this to kind of, on one hand, get brownie points with this contest that we were in, but also it was also to just share, pay it forward. We had a lot of benefit from other people that were in this contest with us, and I was looking for ways that we could barter and trade knowledge. So I collected things that I had learned, taught myself about search engines. Okay, so for this presentation, briefly, we'll take about 30 minutes and talk about some basic concepts and some tools you can use. 10 or 12 minutes on some more advanced core tools, and then another 10 or 12 minutes, actually that's grown now, it's a little longer than that, on just how granular website owners can go and snoop on what you're doing when you browse their site. So it's going to go pretty quickly, from pretty simple to really involved, and there's a lot to cover. So we're going to gamify things. This is no longer, from this point forward, this is, don't think of this as a presentation, think of it as a website, right? So on your screen now is a website. I'm no longer the presenter, I'm now a web server. And you are no longer the audience, you're now a search engine crawler robot, okay? So you're now going to be a robot as you watch this website that I'm serving to you, okay? So what does a crawler robot do? Well, their purpose is to quickly scan through the website with its presentation, to kind of quickly get the concepts and make an index of the pages, right? You're not going to copy down the page. You're not going to explore every detail. You're not going to follow every link. So what you'll do is, if you see a shiny object in here that catches your interest, guess what? There's a page, I call it URL, but you can just copy down the page number, make a note to yourself. I have a couple of points in here where if you don't feel comfortable interrupting, we can come back to this specific page and answer any questions. Realize that I did this because when I gave this presentation last summer, there was about 30 or 40 people, 20 in the room and another 20 at 3 or 4 other sites around the globe. So I had to do some cat herding, and they were a very vocal group. So this was a very helpful way to collect questions in one place. My goal in here at the time was to help people better leverage search engines, because I was talking to business owners and understand what makes these search engine optimizations work and how you could do it kind of at a roadmap level, right? But not at the detailed step level. So for today, for DPRG, I'm using this presentation just to give you a feel for what's happening when you go out and browse the web. And who knows, maybe there's some ideas in here you could apply to your traditional DPRG style robots. So let's just go back to search engine optimization. What is it? Well, to me, it's a continuous alignment process. You've got this content, right? So it's what you see when you go to the website as a human, but it's also that hidden HTML, all those little tags that you don't see when you view the website, but the robots see when they visit the website. It's about the site structure, so how different pages in the website laid out, how do those pages point to each other, how does your website point to other sites. Then there's these grubby technical details that are basically about how do you compile the website, how do you make it happen, and all It's all built on this foundation of sales and marketing psychology kind of stuff, right? So this presentation is focused mostly on the grubby technical details, not so much on these other elements. Each of these other elements are long presentations on their own right, and I'm not as well versed in them actually. So, okay, so now, so let's say that if you're a website owner, what's your role? So your role is to write and design for humans, because at the end of the day, whether it's you as the website owner or the robot, you're trying to manipulate the visitors to your website, humans. So you, as a website owner, you want to coach the search engine robots, and you want to make that AI stuff work for you. Okay, so back to crawler robots, right? There's a lot of different kinds. They each have their own purpose. This is an actual report I could pull from one of our web servers, and it shows the visitors to my company's website last June, and it shows by the name of the robot and by how many megabytes they downloaded in that period. So I looked a little closer at this, and remember, we sell phone service for families with Alzheimer's in the United States. So why is our fourth most popular robot from the Czech Republic? Russia, China, Russia, what in the world? Okay, and then I noticed that these top two, 1/3 of the gigabytes that our web server provided, 1/3 of it went to these unknown robots. They weren't forward enough to announce who they were. And I thought they were trash, because they're probably just pulling away all these ones in red. They're just taking away bandwidth from our web server, and they're reducing how well it works for the people we want to sell to. So I took action. There's tools that let us manage these and dump them and get rid of them. So, you know, again, if you were a website owner, I can provide the how-to on how to do that. So again, back to this presentation, you'll hear terms called like paid versus organic. So organic.
Sorry, Carl, before you go on, are you saying that those were unfriendly crawlers that were ignoring your robots.txt?
Yeah, or we didn't say block them or something like that. Well, certainly these two were the /.bot and the bot/star. So I found some tools. We use WordPress, so I found a WordPress plugin, a freemium tool that lets you just summarily block robots that don't announce themselves or robots that don't respect robots.txt. So basically, if it's called, I have it on later at the end. If they ignore the instructions that you put in your website in robots.txt, then this plugin will say, yeah, I'm going to send all of your requests nowhere next time you come visit. So it's a way to trap badly behaved robots. And I figured even if they're from Russia and China, if they're at least respecting robots.txt, what do I care? But the ones that are bad, there's no need for them. Okay, paid versus organic. This is a marketing term. And basically, organic means where people find your website based on the merits of your website, right? So you have such wonderful content, people like to read it, they spend time on it, they click on it. You don't have to do anything. People just flock to your website because it's so marvelous. Versus paid to be found, right? That's when somebody has a wad of bills and they just hang them out to Google left and right and say, you know, I don't care how good that other website is, I'm going to pay to get to the top of the list of your search results. But we're going to focus on organic right now because, in my experience, you're not going to do so well on paid unless you understand and figure out organic in the first place. So, plus it's expensive to do paid, especially if you don't know what you're doing. So, I argue start with organic. So if you filter out all those ones I don't care about, look at this. These ones in yellow. There's Googlebot, Googlebot image, AdsBot image. So, and then there's BingBot right up above. So you can get a sense already of these kind of what I'll call friendly robots that I care about. And you can get a sense already that, oh, here's one robot. This is probably the organic search one. Googlebot image, it's probably organic, but it somehow is focusing just on image related things, right? So here Google, and then they have a third robot that's interested in ads for some reason. So now already you can see that there's 3 different robots at least that Google has. Each one of them is independently crawling your website to figure out what it wants to learn. 3 different robots. So really I'm just focusing on the first one for now. Everything I've read and learned, though, says that the same principles apply no matter which of these other robots are looking at your site. So best practices for one tend to apply to the others as well. Because at the end of the day, they're just robots. It's just machine learning. Okay, so recap. There's these crawler robots. Their only purpose is to make an index of your website and pages, not copy everything. There's good ones and there's bad ones. And there's tools where you can monitor them and manage them. So as a website owner, you want to sell stuff on your website. I mean, I got some tips I can share. So how does search work, right? Let's go back to, let's start with Google. Type in the word shoe. That's a term we'll use. We'll call that a query. But it's not much of a query, is it? So Google came back and said, we'll put this page up. We'll call that a search engine results page. And if you see it on some of the blogs, they might call it a SERP for short. But you'll notice that it has men's boots, men's tennis shoes. It has stores that are very close to where I live. And it has this little thing on the side. Well, it found about 8 billion relevant items to shoe. It made a ranked list, and 0.82 seconds later, it presented that to me, right? So did it go through and crawl however many websites it takes to find 8 billion occurrences of shoe? Hell no, it searched its index that was pre-compiled. So let's dig in a little bit further. So I only typed shoe. So how did it decide what to show? Well, it had meaning Google's search engine, had to guess my intent. So in this case, maybe I wanted to go learn what a shoe was. But even if I wanted to do that, okay, Google put that up there just in case. But here's Google. So maybe it said, I know you might have wanted to learn what a shoe was, but ignore the Jedi mind trick, right? Let's go shopping instead, because that's how Google makes money. So look at how it emphasizes the results based on how it interprets your intent and what it wants your intent to be, right? So it's already trying to manipulate you just by how they present the information. And there's context, right? And the thing to remember is that between search intent and context, there's a whole ton of AI going on, and that adds color to the word shoe or whatever you type for your search query. So then it compares the search engine, to this giant indexed map of context. So Google is out there constantly searching your website and trying to make sense of it and decide how it relates to your index, its index. But after it starts with your query and it figures out search intent, context, and this giant index map, then comes an auction, right? As I showed you, Google has several different search and several different robots. So you can imagine on the left hand is the organic robot, and it said, well, here's the list of the best pages based on their own merits. These are wonderful. This is what that person's really looking for. And then on the right hand, there's this greedy ad bot robot, and it says, hey, I know the guys in the head office need another mega yacht in the Caribbean. So we want to put these ads. These are the best ads that person needs to see. And then there's this third robot in the middle that says, okay, if all we do is show organic results, then the guys don't get payment for their mega yacht. And if all we do is serve ads, then the viewer is going to say, I don't need any more cheesy ads. I'm going to go to Bing. So this robot in the middle is arbiter, and it'll say, I'm going to shuffle and mix together the best organic and the best ads, and then give you that search engine results page. And then I'm going to look and see what the people click on as a result. Okay? So let's recap. Now, what's really going on under the cover then with this machine learning, you got a query, shoe, and it's got some kind of weighting factor. Search intent, let's assume they want to go shopping, because they didn't say shopping, so we'll have another weight for the search intent. Context, man near Castle Hills in North Dallas. So that's the third weighting factor in this case. And then this giant index, what are the stores and locations in that area? And that gives the search engine results page. But then, like, imagine I type some other things. How are shoes made? My shoe hurts. Tie a shoe. Well, you can imagine how shoes are made is pretty clear. But my shoe hurts. Well, okay, smart enough software. It's going to figure out they're looking for shoe-related foot issues, really. And tie a shoe, what they're really looking for is how to tie a shoe. Maybe context, right? Maybe age is more important. Favorite sport, like I didn't see my red ballroom dancing shoes in my page, right? Because it knows I'm a guy and I don't do red ballroom dancing. So, and maybe instead of stores and locations, how readable the web page is and how old it is, how quickly it puts in your browser. So all these different factors come into play when the machine learning decides what to put on that first search page after you type a search, right? So let's recap. So the robots, they're constantly experimenting on us. They're trying to do a best fit optimization. They're trying to maximize how many people see your page, how many clicks people get on your page, or then after that, how many times people buy. And these robots, they're constantly retraining themselves. They're constantly, hi, Bunny. They're constantly adjusting these weighting factors. So, so why should you care? Again, if you're a website owner, business owner, why you should care about this is that it takes time and iteration. Because once you make a change in your website, it can take a while for the robots to go do all these A/B tests on people and adjust these weighting factors to figure out how to get your website in front of the right eyeballs. But the good news is that as a website owner, you can speed up the process. You can give guidance to the robots and help them understand what you're trying to do. So to do that, you need a goal function, right? You've got to have a way to measure success. Well, for me, my company, it's about sales growth. So I pulled this chart together, and if time is left to right and number of sales is up and down, I have a way to figure out which search engine was giving me how many sales. So I've been able to, it takes a lot of work. I can't automate it yet, but I can attribute the sales to where they came from. So the big question is, right, why did the rate of sales change at this period of time? Turned out that over here, we paid an agency thousands of dollars, made 0 sales. Experts failed. So I tried some do-it-yourself paid advertisement. I did Google AdWords basically, and I actually had some sales, more than the experts, so infinitely more because they had 0 and I had some. So then the next step was that at this period of time, I made changes to the website that I'll show in the next few slides, and you can see that right after that, then the sales kind of took off. So that's when felt like it really got arms on the system, arms around the system. And this put a time scale to it. This was 1 month over here, another month, another month, another month. So it can take some time, depending on how much traffic comes to your site. It can take at least a few weeks for the robots to start to dial things in. So about measuring success, the old adage, you get what you measure. So I'll add on the corollary, you better measure what you want. So before we speed up a little bit, anybody have some questions for a brief pause here? Just jump right in. Okay, if not, then let's talk about some tweaks. There's a tool called Slack. It's like—
Oh, sorry, Carl. Hey there. Just a real quick question. Organic, is that unpaid? I missed that. Sorry.
Yeah. No worries. It's in recording. Organic it means your site is found based on its merits. So how interesting is the content? How long do people spend reading it? How many other websites refer to your content? How many times do people click within your website or take actions and convert? So organic is when your website scores in the search results because of its own merits. Paid is when you stand there with a wad of bills and you give Google or Bing or whoever money to move to the top of the line.
Okay, thanks.
And then, yep, and then there's arbiter robots out there in the way a search engine results page is built. These arbiter robots, they look at how when somebody types in a search, the robots will say, well, what are the best pages on their own merits? What are the best pages based on money to Google for paid advertising? And then these arbiter robots, they try to maximize profit for Google by mixing paid ads with organic on their own merit results. Hey, Steve, welcome. So that's the difference there. All right, so let's speed up. So Slack is a tool. It's kind of like old AOL Instant Messaging. It's just a way you can chat with each other. And I bring it up because it's an easy way without any money to go figure out how does your website look. You can deduce how does your website look to the robots, and are you doing the right thing on your website for the robots to do their job? So before on the start of my journey, this was what our website looked like. I typed that URL into Slack, and it came back with that information. That's how it would look. So if I shared it on social media or something, that's how my website would look. Hi, Mr. Dave. You got a question? Can you type in your question or go off of mute, Dave? No audio, Dave. There we
I'll
go.
attempt to read his lips. Just a minute. I'm a good lip reader. I'm teasing.
He's got audio now. Dave, what do you got?
Oh, I just have, it's very hard.
Turn your speaker down. Turn your speaker down.
We might use chat over on the slide there.
I have actually two connections running. I'm experimenting with this iPad,
Cool.
but it doesn't seem to work very well, so I'm going to turn it off.
Oh, okay. Did you have a question then or a comment?
And I got to put my headphones back on to hear.
Okay.
That's all right. So, yes, Hodges Bunny is my wife, so I have her iPad. And I was trying to see if I could make it work. So I'm sorry to interrupt.
Oh, no worries.
I'll turn it back off.
Oh, okay, cool. No worries. Okay. So the thing is that if you have a website and you want to make a change, you have to know what to change first, right? So I like Slack because it's well, we use it on my job, but you can just type a URL in there and it comes back and it shows you this website. Well, let's say that you're an investor or you own the company. Whoa, we like our logo. That's really good. But let's say you don't know anything about telecom. You got a mom or a dad with Alzheimer's. Are you likely to click on that? And I thought no. So get to the right page here. So I spent about 90 minutes in the WordPress tool. I adjusted a few things to coach the robots. These are like hidden tags that you don't see necessarily as a human, but the robots see them. So I just manipulated what I put into the website, again, specifically for the robots to see. And I did the same kinds of changes also for Facebook and Twitter. So sometimes these robots are so important that they're special, right? So they have special ways you can manage them. So I made those changes. The whole intent was that I want to recommend these robots add specific content of mine in their index so that they better understand what I want to be conveyed about my website. And then after 90 minutes, I pasted the same URL to my website into Slack, and that's what came up. So now ask yourself, which of those is going to be more appealing? Which of those tells you more about my company's service? If either of those comes up in the search results, which one are you more likely to click on, right? I think it's night and day. And the data shows that as well. And it only took 90 minutes in knowing how to stick that in there to help the robots. You can also use iPhone or Android the same way. If you copy paste the URL and send it to somebody, you'll see here in this case, this is exactly the same URL at the same time, but the Slack robot decided to pull this information and present it. And the Apple, in this case, it was an Apple robot, decided to show this about my website. So the whole idea is that if you own the website, then you want to have your information kind of modularized and presented to the robots so that no matter what robot is looking at your website, they can pull up relevant and interesting things no matter how somebody decides to share your website around. And in a nutshell, with a nice simple example, that tells all the difference, right? Because what a difference that makes. And then as you see this, you browse around, you'll start to notice now sites that do this well and sites that do this poorly. Here's another example. And there's a concept of conversion funnel, and UX stands for user experience. This is a page from our website, the plan selection page. So we offer 2 different levels of service. This was the pricing at the time. And this was how the page looked before the tweaks. So I went in and I did similar things, and that's how the page looks after the tweaks. Now you might look at that and say, not a hell of a difference, right? It's pretty similar, even if the price was the same. But get this, even though the price went up, even despite that, look at the difference in results. Average time on the page was up 94%, from 50 seconds to 1 minute and 36. Number of people entering that page up 142%. People bouncing over to cat videos down by 17%. Leaving this website entirely down by 26%. So pretty simple changes, right? Just in how you present the information, both to the humans and to the robots. So that was really positive to find that data. And that's just a marketing thing. So basically, if you have a website and people drop to any page in your website, you want to keep them engaged in your website. And this is actually something I want to work with Doug on for DPRG. What the whole idea is that you want people that care about you want to have relevant traffic, people that really care about what you do, and you want to drive them deeper into your website, whatever you want them to do, whether it's click another link and spend time, or whether you want to capture their name and phone number, or whether you want them to buy something or call you. So basically you have to decide what you want to do on a website and set up the tools and then optimize around that goal function. And then there's a checklist, right? So you want to know who it is you're talking to. You need to summarize what your goal is, keywords. So what things are people going to type that will most likely you want them to drive, that those search words you want to find your website by. And your goals might be testing a hypothesis, or letting people know, or driving people to visit, or lots of different goals you might have, or some combination of goals. And then there are these kind of core tools we'll talk about briefly next. And then you need a measurement plan and feedback and iteration. So let's talk about benchmarking tools, so that more free tools. And let's look at the world through the eyes of a crawler robot. So this is one tool. It's called SEO Quake. It's just a free plugin to your browser, well, freemium. You can use it on your own website or anybody's website. It's kind of fun, kind of interesting. So this was one of our web pages. Click that button, this button, and just on this one measure here, there's many measures on this page. One measure is called the meta description. It says that's optimal. Got the right number of characters, looks good. And what happens then is that the robot knows your elevator pitch and stores it in its index, or shows it in Slack, right, or wherever you share it around. If you instead do a page audit and you see this, 0 characters, that means the robot doesn't have a clue. You're not helping the robot, you're not showing the love, so it has to guess. It has to read through all the content on your site and try and decide what it's about. Headings are another thing. So you know how you have big, bold things in outline form on your website? Well, if you think of them as an outline and you structure them like an outline, That's really good because it helps the robot learn the concepts. Doesn't have to memorize all the details because you've got the contents nicely outlined. But instead, if you have these kinds of headers, just look at these. It has 4 H1s. So what's that website about? It's just a bunch of numbers. So clearly the website designer was using H1s to make it big and bold and colorful, but they weren't paying any attention to the robots. So the robot, I mean, it's going to be clueless as to what that website is about. No, it's no help there. Keyword density is another thing. So this is keywords can actually be phrases these days. So the keyword telecom essentials or phone service, these tools will tell you how often those keywords repeat on this page and whether they're found in these robot-friendly descriptions in the HTML or titles. Another trick you can do, you can copy and paste the HTML into this word cloud tool, and then you can just ask yourself, do I have the right concepts coming through in the word cloud, just without reading anything, just glancing at it. So it's kind of a handy trick. Another tool is called page authority, domain authority. So these are another factor that the search engine robots have in their context and their page index. They basically, it's like E.F. Hutton, right? When somebody talks, you listen. So the search engine robots keep a map, this giant graph of how many websites point to your website and how many times people follow those links to your website. So they tell how influential your website is by that. And the more people that refer to your website and drive people to your website, the higher authority you have. So the idea is that the higher your authority, the better you'll rank, more traffic. It'll cost less to get paid ads. But those things take time to build. There's this funny concept called link juice. The idea is that if you can get really authoritative sites to point to your site, then the authority of the high authority site carries by link juice, it's assigned to your site as well. So if you have a lot of high authority sites point to your site, it'll elevate the authority of your site. So that's the trick. Like if you're a website, to get journalists, to get CNN or ESPN or somebody like that to point to your website, because then that'll boost your authority. Another benchmarking tool, this one, I'm picking on Microsoft. Sorry, Steve, but you can put any old website in here and it'll give you page load speed. And Microsoft homepage is not doing very well. But the nice thing is this free tool tells you what to improve and what you can change in your website to boost your score. And the cool thing is that you can either test your website from the point of view of a desktop browser or a mobile phone browser like an Android. And you can get different results because they're different browser environments. And there's lots of tools like that out there. Okay, so there's free tools. You can do sanity checks to assess your own website or somebody else's website. So the triage is easy, but stopping the bleeding and fixing things can be a little more time consuming. Okay, another break point. Any more questions real fast here? All right, so let's jump on. So core tools, Google Search Console. All right, so when we have programs in Linux or Arduino, we write console logs and we can see what the computer is thinking, right? Well, as a website owner, if you want to see how Google search engine views your website, what you do is you prove to Google that you own your website. Then Google will let you log into their computers and they'll reveal data that Google has on your website. So they'll let you see your own website through Google's eyes, if that makes any sense. And you can do that from a tool called Google Search Console, which is organic, Analytics, which is like a aggregating thing that pulls in data from a lot of different places, and then Google Ads, used to be called AdWords, which, as you might imagine, is where you pay for ads and run campaigns. I bring this up even in this context because they have these cool little tools in here that you can use for free. Funny aside, I learned about Google Ads in a LinkedIn class because they were suggesting to use the keyword planner to get keywords for your resume on LinkedIn. And you just get a free account on Google Ads, and it's kind of neat. So there's some neat tools out there, how to use them. Okay, so let's start with Google Ads. This is where you can benchmark the competition. So there's a lot of people, as you saw, 8 billion results for the word shoe, right? So there's a lot of competition for that keyword, and that competition might be different in different places. So like you can imagine, snow boots might have a lot higher competition in Fairbanks, Alaska than Hawaii, because how many snow boots do you buy in Hawaii? So there's a pretty complicated system out there. So I'll just show you this ad preview and diagnosis tool real quick. You can select the context in here. So from Dallas, Fort Worth, language English, from a mobile phone. We'll type in this awesome keyword. I'll tell you offline, but not in this recording. Note that I found that awesome keyword because I looked at what the robots found when I looked at the Search Console. I would never have guessed it otherwise because it was a 8 or 10 word phrase, but it was awesome. When I put that in there, I got the #1 organic search result for a mobile phone, which is really hard to do. It's really hard to get the pole position like that, but that one, I didn't even know it was out there. I would never have guessed it, but the robots found it for me and told me what it was when I knew where to look, which is good because organic, that's free advertising, right? So I said, well, maybe it's an anomaly. We're based in Dallas. Let's try where there's a higher, older population. Let's try Orlando for a mobile phone. Same thing. Poll result. I mean, top of the list. So then I said, well, wow. Could this be for real? What happens if I try it again? So a minute later, I redid Orlando, and look at this. We dropped from the first position to the second position. And what's up in front of me? It's a paid ad. So think about it. What's going on here? The robot is experimenting on me. What do you want to click on? You want to click on the paid ad, or are you going to click on organic? What's more important to you? So it's experimenting on the viewers to figure out how can it maximize ad revenue. So there you can see, what an experiment looks like when you're being experimented on. Thankfully, for this specific keyword, whenever I run it, 9 times out of 10, my website gets the #1 position. But that 10th time, a paid ad, they'll dangle that in front to see if anybody bites. So another one is a keyword planner, another tool in there. You can load a list of keywords like shoes or how shoes made, or the third keyword, my shoe hurts. So you type in list of keywords. You can look at a date range, and you can see, like the word shoes, over a month, there was 1.5 million people that searched on that keyword. If you want to buy your way into it, it costs $1.57 a click. And the competition ranges from 0 to 1. So 1 is really competitive. There's no competition for my shoe hurts, it's 0. And there's a lot of competition for the word shoe. Average monthly searches are 1 to 10 million. So the bid range, okay. So here's another tool, Keywords Everywhere. It's another free plugin. Once you add that into your browser, you as a website owner or just somebody who's curious, once you plug that in, it adds this extra stuff. It adds, it pulls, you link it to your Google accounts, and it pulls the search volume and cost per click, and it pulls up a list of related keywords. So if you're trying to figure out how can you boost your website to the top of the search page, this tool can tell you, gives you some ideas on how you might do that, and what it would cost to buy your way to the front of the line. But if you're just curious, it's kind of interesting sometimes to see as you browse around, what are people searching for? Okay, Search Console is another one. This is the view into the organic search robot. So your site on its own merits from Google's search bot point of view. I like this landing page analysis. So I can look at pages over a time range, which means I can pull down a report like this. If each row is a different page in my website, I can look at like how many times people saw it, impressions, whether they decided to click on it or not, and then where it was in the page. So a smaller number, if it's number 1, you're in pole position, you're at the top of the list. If it's 18, you're number 8 on the second page of results. So your goal is to get towards the top, like these two on the bottom here. So, but you have to be careful. I mentioned before, you get what you measure, and some of these are vanity metrics. At the end of the day, I don't care about any of these. Sales is what I really care about. But these are intermediate metrics. So queries are another thing. So this tells you what are the actual queries that people are typing to get to your site. And you can compare that to what the advertising robot thinks it would be. So if you use this Keywords Everywhere plugin. So you can download that again to Excel. And right off the bat, I would say, look at this. How do I find out who keeps calling me? It's low volume. It's really high competition. If you type that as an advertiser and you pay for it, Google will charge you $7.27 every time somebody clicks on that. So if you're an advertiser with an ad that triggers on that keyword, you're going to pay Google $7 every time somebody clicks. Right? So in our case, it was organic. It showed up 332 times, only 5 people clicked. So I'm calling that junk. This one I call an opportunity because senior phone service, it's relevant to what we offer. It's a bit higher volume. $1 a click is kind of the going rate for AdWords, or a decent rate, not terrible at least. I think it's an opportunity, whether we pay for it or try and do things organically, improve our content to improve the organic results. But then here's our awesome keyword, and this is how I found it. Because Google Ads thinks there's no volume, nobody cares. It doesn't cost you anything to get for it. It surfaced really low number of times, but look at the ratio. 1 out of 8 people clicked on it, whereas this was a lot lower, right? So 1 out of 8 clicked on it, and I know from later on that actually 2 or 3 of those 5 bought our service as a result. So this is, this is what they call that opportunity, because Google doesn't know, and I can get it for free, and it's working for us. So that was a really interesting thing to find, and that's really helped us in the last year, actually, as we figure out what to blog about and how to draw people in and convert them. Another thing is the URL inspection. So if you make a change, you can test to see whether you're making the Google bot happy. And you can ask Google to add you to the index. There's no guarantee they'll do it or not. And then you can go check to see if the Google bot actually was successful, if you're indexed or not. So if on the other hand you get something like this, the robot has looked at your page and decided that it's not mobile friendly. Things are too close together, it doesn't fit on the screen. So these are bad, right? Because if the robot thinks your page looks bad, how do you think you're going to do in search? Not so well. So you'd never necessarily know this without looking at it through Google's eyes. So Google Analytics, this is the one that pulls together data from a lot of different sites. It has this kind of real-time overview. So I can go to this page and I can see right now who's on my website. Well, at the time I took the snapshot, there was 3 people. One was on a tablet, one was on a mobile, and one was on a desktop. And they happened to be on these different pages on my website, and they happened to be spread across the country. So that's kind of interesting. But if you're a business owner, you think, well, wait a second, right? Who has the time to watch that all day? So I asked, I thought that for the first year or two. Then I thought, okay, what would brick and mortar do? And I realized, if I have a little brick and mortar store, a little bodega in New York, I'm going to stand behind the counter And I'm going to watch how people walk around in my store and interact. Which end cap are they at? Where do they spend their time? I might not interact with them, but I'll keep an eye to it. So what did I do? Grabbed a Raspberry Pi and a spare display. I looked over now and then during the day, and I noticed something that I didn't find any other time, any other place. I noticed that people were getting to our shopping cart, and then they were abandoning. They weren't making the purchase. So I thought, okay, maybe we need to change something. Maybe we need to have one of those things that pop up when the website notices they're in our shopping cart and say, hey, we see you're about to close. Can we help you close this deal? So anyhow, it was really revealing to find that. Behavior flow, I mean, just look at all the information that's available out there. People can find out about you on their website. So you can sort by, I like to sort a certain way, and it sorts by, like here, you see Facebook at the bottom, paid ads, Google organic, others, which means Google doesn't know where they came from. But anyhow, it sorts it by the most number of groupings of the most number of clicks to the least number of clicks. And then you can see what pages they landed on, from the page that people landed on most often to the page they landed on least often. And you know that if it's got this little red thing, you lose because they're abandoning your site. But if you see this, they're interested. They want to see more about your stuff. And it just goes on and on. So you ask yourself, what can I do with that? Well, you can highlight the path, and you can say, well, for all the people who found us organically, what was their experience, in the aggregate, and how does that compare to paid? So now if you were to look at this and ask yourself, well, which one of these is better? At a glance, you might say, well, clearly organic is better than paid, because look at how much richer it is. But then I might come back from another thing and tell you, well, but what if I told you that every one of these paid ones turned into a subscription, and none of these organic ones turned into a subscription because they all got to the shopping cart and couldn't check out? So the point is that this can be an insightful tool to see how people are behaving, but it doesn't necessarily tell you what you need to change. So for that, you need conversion goals. So in here, you go into Google Analytics, again, this Google console, and you tell the robots what's important to you. So I picked a page that basically says, okay, they've actually just purchased. I want Google to know, I want Google to count every time somebody completes the purchase on a website. And that helps coach the Google robots to know, so that they understand what I think success is. So once you do that, then you can go back, and through a bunch of analysis, you can start to close the loop, okay? So what that means is, let's for example, track from a specific customer, from the point that they searched and found us to the point that they purchased. So we'll go back to Google Analytics again. And here we have a list. Every row in this column is a unique client ID. Okay, Google is anonymized. They don't provide me access to your name, phone number, social security, nothing. It's all anonymized. It has to stay that way for various reasons. But it keeps track of the interactions for each person. So let's pick the one at the top of the list, because I happen to know from the machine math, 300% usually means somebody just purchased. So I sort this list by the goal conversion rate, and then I click on, I know that person aggregate of 37 minutes when I did this sample. So let's click on that a few times and look at this. We know that on Wednesday, that's when that person found my website. It was 8:18 a.m. They were on that page for they were engaged there for 7 minutes and 49 seconds. They found us from a mobile phone, iOS browser, and it was an organic search. That's starting to get granular, right? And then after that, they interacted with my page or my website 3 more times that day. And then a few days later on Saturday, they came back, and that's when they purchased. Okay, let's drill down. So if we drill down into this particular part, the very first engagement, On Wednesday, we can see they started off on this specific page. That's when they discovered it. They were there for 6 minutes. That's fine because it's a 2,000-word blog. It takes about 6 to 8 minutes to read it all the way through. Then they bounced over to the how much does it cost page. And then they quickly went to what does it take to subscribe. And then they went back to this big long blog and said, I need to learn more. So 7.5 minutes total. They got a sense of it. Then they came back 3 days later. They laid it on the same page. Then they started a text chat with our sales team. Well, this is cool because now I know how they first found us, and I can compare that to what was the discussion on the chat, because it was a full like 30, 40 minutes later before they purchased. So did our chat transcript, did our support people close the deal, or did they just stretch it out and make it like on the edge? So you can imagine that if you put all this information together, you got some really detailed information and clear insights on what's going on. And going through that process now is how I added one data point to this chart, basically. So this whole process, this whole painful process of looking at this kind of stuff, I did it quite a few times to get this chart. And then I haven't done it in the last year. But there's even more rates, though, because you can go back in here and you can dig out more information, and you can add in the sales data. So now I can see for which page, for which page, how they were performing. So I know, like on this page, I had 20 new sales, and it had 4% of the time that somebody landed on the page, they would sell, they would purchase. This one had 4, and this one had 2. So you can now start to see how these different pages, which one's working for you, and you can start to go back and figure out why. And then you can make changes. So now we have feedback loop, right? We have a feedback loop because we start off with who are we trying to reach and what are we trying to accomplish? What keywords do we want to trigger to drive people to our site? We tweaked and used the tools to figure out what we needed to measure. And now that we've got some data, we've gone through once, so now we can go back and, have we defined the audience well enough? Maybe we need to drill down and target a more specific age or demographic for a customer. Or maybe we need to change the keywords, right? So this is how the closed loop works, basically. And I'll share these with the club. And if you have anything you want to share or trade for, I'm glad to help you with this stuff. Club offer, I'll help any of y'all anyhow, because we're good friends. And this basically was it. So that's what I had to share. Any thoughts or questions? I see you clapping. Thank you very much. I'm going to stop presenting. Open mic time. Just jump right in with whatever you'd like to say or observe.
When will the robots take over?
They already have. The robots are here, but I like to drive them.
Well, that's pretty fascinating.
And doing all of that stuff.
Say what?
How much time did you spend doing all of the, improvements and stuff? It seems like a lot of work.
Well, the presentation alone, to make the presentation was about a week, a solid week, 40 to 50 hours of time just to make that presentation. And that was only so fast because I had spent, it's been an interest of mine. So I've been looking at things on and off for a few years, but really, and I've been going, there's a handful of meetups around town that are really good. And I've been participating in them on and off for 3 or 4 years or longer. But in the last 3 years with this startup, I've spent, I don't know how many weeks and months overall, because it's been spread out over 3 years. But I've run I think it's up to 3 specific attempts at a pay-per-click ad, where I said I want to pay so many like dollars per click if somebody types this keyword, and I want this web page to show up as an ad in search results. So I've tried that 3 times, and it's been expensive, and I've learned a lot, and that led me to learning on organic. So then, I would generally, when I do this, I'll go in and spend about a week at a time and really focus on it for a week, change content on the website, figure out on the blogs, learn how to go adjust the tools and drive a little better. And then I'll go run an experiment. So I'll go like run an ad or change the website, and then I'll go watch it kind of a few minutes or an hour a day for a few weeks. And then I'll go, okay. And I'll tuck that away, and it'll just sit there and stew, and then I'll come back another few months and do it again. So, but yeah, it has been some time, and this is now my 2nd year of being a full-up member of the Search Engine Marketing Meetup, which is pretty cool. It's mostly people who do this in the agency, so they do it for pay for a living. But there's a handful of DIYers and just interested parties like myself, and it's just been awesome networking, because that's when you see how the people who do it for a living learn to drive, and they're sharing tricks, local consultants. So that, like, they have an entry level for individuals, $200 a year for a once-a-month meeting, and I'm now in the 2nd year of that. And I've found I've used I've worked with a handful of the local guys, either pro bono, or as soon as we can get some budget, I'm going to hire 1 or 2 of them now for different things.
Wow.
Because I understand better what to look for. I know how it should work. I've seen the paid agencies that are bozos and don't know how to drive. And I believe from interacting with them and trying stuff that I know which ones I can trust now and how to select them.
Carl, can you hear me? Is my mic on?
Yep, I got you.
Oh, great. We put together our first web server up at SMU in the geology department. It was back in the early 90s. I can't remember a date. I looked back at the Wayback Machine to see when it first captured them. If that's the closest I have. And it's changed hardware, but basically that one machine has been in operation since that time for so maybe 25 years or something like that. And in the early days, basically all I did was I kept the server logs. And so I would go through and look at the server logs as ASCII data. And I've actually done that hundreds and hundreds of hours. And so in those times, when you got an entry in the server log, it included what reference that link came on. In other words, it would say, this IP address is hit on this particular web page, and they're doing it because they're coming from this web page on this other machine. And after a while, Google et al. Stopped doing that. So you couldn't actually tell what search string they had used when they were looking at your specific. You had to go ask Google what search string they'd used. But one of the things I saw was in 2003, I put up my web page for the two-wheel balancing robot. And very shortly thereafter, it bopped up till it was number 1 on the Google search. When you typed in two-wheel balancing robot or even two-wheel balance, the rest of them would be like how to balance the tires on your car. The two-wheel balance would hit on my webpage. And it stayed that way for 10 years. Into 2013, it was the number 1 hit for two-wheel balancing robot. Now, there's so many of those out there now, I'm way down the list. But somewhere along in there, SMU came to us and said, well, we're going to have our own servers now, and you can't run your own web server anymore. And so that really disappointed me. So I went to the head of our department and I made a big argument about why we needed to maintain our own web server, and it was convincing. And so they let me do it. I think the only one on campus that's not run out of SMU's data center. So I have that web server has been running essentially continuously. As I said, the hardware's changed, but overall this time. But a couple of things have happened differently. One of which is that there are now so many other machines out there that link to that server. There's even a link I found one time from a couple of patent applications that link to pages in my web server. And I would guess conservatively that there are 100,000 links to my web server that have gathered over the 25 years, such that digging through the thing by looking at the logger files is not doable anymore. It was just a little web server that a few other geology departments accessed at one time, and I could tell who was getting in and what they were looking at and so forth. But these tools that you're showing, as a matter of fact, while you were talking, I loaded in the SEO Quake and looked at my website with it. Provide a level of detail that's actually pretty astounding.
It's neat stuff. And then, I mean, to your credit, Dave, look at this. I just typed two-wheel robot on the search, and here you are. Here's your robots, right? You made the. I mean, it's hard to get into this kind of position, and you're right there.
Oh, look, it's in there twice.
Yeah, that's what I'm saying. And so you have, that's pretty good. And then Google is so interested about sharing these multimedia things, videos and images. And people always ask that, but still on the text list, 1, 2, 3, you're number 4. You're on the first page, number 4, man. That is hard. That is hard to do organically. And then here's I'll just show you. You can see, it's a low volume search, 170 per month, but it's relatively high competition. So for a high competition and low, I mean, you're doing well. It wouldn't cost much to get the clicks if you wanted to buy. And then here are some related keywords over here. So these are like people also search for kinds of things. So isn't that interesting, huh?
Very much so.
But yeah, and then I was also going to look. This tool is kind of a pain in the arse at times when you don't have it on all the time. But why can't I? Usually, so this thing called Mozbar. I was going to look at your domain authority because it has to be pretty high. But I usually have it trouble turning.
That if you see up there, it says not secure. I'm probably one of the few websites left in the planet that just runs HTTP, not TTPS. Just because I've been too lazy to upgrade. But I noticed that that caused it to fall down in a lot of the rankings. The fact that it's not a secure web page.
Yeah, that I bet you could easily rank up a bunch higher if you took care of that. Relatively simple change.
No, that's good. That's good information to have.
Absolutely, yeah. Yeah, especially in the last few years, that's made a huge difference. I can't get this to run. If I get this run offline, I'll see if I can send you your page authority and domain authority, because those are maybe we can just find a different site that works easier. Your Ahrefs is good.
What I've done is I wrote a little shell script called wgrep, and with it I can grep through the log files if there's any particular things of interest I'm looking for. So if I want to see if anybody's downloaded a particular video, I can run a web grep and we'll just pull out links to those, and I can see, oh look, somebody downloaded that Venus video that I made 20 years ago. But there's a lot less information in the logs than there was at one time.
So two things, right? So here's look at this. So there's, among the many crawlers out there, there are these search engine websites, and they sell services for like marketing agencies. So one is ahrefs.com, and you can go in there. You've got a domain rating of 82, and maybe that's maybe that's geology.smu.edu, but the domain rating means, remember E.F. Hutton, when somebody speaks, they listen. So 82 is a really high domain rating. That means it's a very reputable site. It means
That's good. Is that good?
excellent. It's gonna elevate your results in search, basically. But that's the domain rating. What we want to do is the page rating, page rank check. Let's see. Page authority. So let's try your specific page. Page authority checker. Checker. If I could type straight. Minded.
That's the Czechoslovakian spelling, I think.
Yeah, it probably is. A lot of these, yeah, so many of these they lead gen. So we'll look at that offline and try and find out. But I'll bet your page has a pretty high authority. So you're probably getting some lift because SMU is a reputable site, SMU. But I'll bet your page is ranked well too as well. So there's the authority of this domain, the domain itself, and then the authority of individual pages.
Well, back when I was able to collect that kind of information, I did see that Balancing Robot web page was linked to by a lot of master's thesis and dissertations.
Yeah.
And as I say, I found two different references on patent applications. Both of them were using that as a site to prove that there was prior art in order to protect themselves basically for the balancing algorithm itself.
Yes. Yeah. Yeah. Let's go look at that. You got me started now. But there's all kinds of tools out there that are useful in that. The other thing I was going to offer is that I think from the sound of it, if you're interested, you'd really benefit from getting yourself set up on Google Search Console and Google Analytics. And since you're in control of the website, it should be really easy for you to prove that you own those properties, that you own. Well, no, you're going to have trouble proving that you own SMU. Yeah, so you might have trouble doing that.
Yeah, I've had trouble with that before.
Okay, so you're going to have trouble with this. But if you could talk to the webmasters at the smu.edu and ask them for Google Search Console and Analytics info, they'd probably give you some neat info on your page.
I'll have to think about doing that because they really don't like the fact that I run my own server. When they put up the new firewalls at SMU a couple of years ago, and they sent around okay, no machines are going to be accessible from off campus anymore unless you tell us a very strong reason why yours should be. And I went to him and I said, well, I have a strong reason why this one should be, and I told them a bunch of things about how the Air Force and other people access to get data from that server, which is all true. And they begrudgingly allowed a hole in the firewall for my server. But I'm probably wise to keep a low profile about the whole thing.
It does sound that way. All those spoil sports. What a bummer.
I'll tell you, if my job was maintaining security for a large university campus, I think that would be a nightmare. People coming on and off campus with their laptops, hooking up to Wi-Fi, and it's just not. It's not a job I envy.
Yeah, not at all. Been that way since the 80s. Yep. Since I was sitting in freshman math, calculus or something at CMU, and what should happen but these two agents show up at the door, talk to the lecturer, and they marched out somebody who was a friend of my roommate because they had hacked into Cornell.
I've always just been one jump ahead.
Yeah, pretty much. Okay, so any other thoughts and such on robots versus humans?
Carl,
Yes, sir.
so Google Ad Grants gives nonprofits $10,000 a month worth of ads credit. Are we using that for DPRG?
No, I didn't realize. That would be great. Could you send me the link? I mean, I've been wanting to go talk to I think before we do that, there's some stuff I need to talk to Doug about just to get some basic hygiene taken care of.
Yeah, sure.
But I think, yeah, if they're willing to do that, you said 10,000 credits a month for nonprofits?
That is correct.
Wow. Are you guys using it for Iron Rain?
No, I'm not fully set up as a nonprofit yet. I sort of dropped the ball on the process of getting the IRS designation for it. So we're a Texas nonprofit, but we have to have our 501c3 classification in order to qualify for the ad grants program, which I think I just put in the chat.
Yeah, nice. Well, that'd be very cool. Thanks, because I've been now that I've learned what I learned in my company, I've been seeing what I think is a lot of opportunity we could do for DPRG.
We are using it for my my day job nonprofit, and it's great.
Nice, nice.
It's pretty easy to sign up for.
Hey,
Wow.
Dave, I was kind of curious about the algorithm. You know, you said there were several papers written referencing the website. Did you create the algorithm for balancing, or did you have to, you know, I guess, document who did and where you got it from? And so they did too?
As best I know, the algorithm I came up with is my own. When I was doing all this back in the early 2000s, I did a bunch of hunting around online, and I found that there actually had been a two-wheel balancing robot built by a fellow in Japan. He's actually referenced on my webpage. As a matter of fact, I think when Segway a few years later came out with their balancing human transport vehicle, that he and they kind of went round and round, because he said it was his invention. But if you look carefully at the Segway patent, which I have, I've read the whole thing. I will accept your condolences. It is not a patent for a two-wheel balancing platform. It is a patent for a human transport use of a two-wheel balancing platform. As best I could tell, and I actually had gone at the time and talked to some people at SMU about what I had done, and I told them, you know, what I was doing, and that my take on it was that I was a hobbyist. I wasn't intending to make money out of this, but I didn't want somebody else to patent it and say it was their idea. And they suggested that I publish, and that was the way to protect myself from having somebody else take the ideas and patent them. And so that webpage basically was my publication of the algorithm. Was that your question?
Yeah, I was just kind of curious. So they were doing it because you had published, and you know they I guess just needed to document that, so that, you know, plagiarism basically, right?
I think that they were trying to protect themselves if somebody else came to them and said, "Oh, you can't use that balancing algorithm. We own that." That they could go to court and say, "No, you don't. Here's the prior art."
Oh, okay. Yeah.
My understanding is that that's the way it works. So let this be a lesson to all you clever robot builders. If you come up with something cool and you're not planning to monetize it, get it published quick before somebody else takes it and claims it as their own.
If we only had those base ideas, Dave, I think that's the key.
Well, haven't you ever had one of those aha moments when you come up with an idea, maybe you implement it, maybe you don't, but then a couple of years later you see somebody else came up with it and they did patent it and make money off of it. Oh, yeah. Whereas we just sat around. I have more than once.
Yeah,
it was just like something we sat around the dinner table and discussed and then dropped. And then you know.
I've seen it. I'm wondering now, Dave, that if things like just publishing, if you did that and did it on GitHub, I mean, that's a pretty public forum. So I got to think that could, and it's traceable by timestamped encrypted hashes, right? So you can actually show a history and progression of the idea if you publish on GitHub. So I wonder if I got to believe that would count as well.
If that's the case, then probably we're all pretty well covered anyway.
Probably what would?
We're probably already well covered because so much of our code is on GitHub.
Yeah.
With that.
I think so.
Yeah, there used to be this show called, I think it was Medium, and the woman had these premonitions, and the premonition was, or when it happened, she was like sleeping in bed, and she kind of rose up, and it's like you talking about those kind of moments, Dave, or?
So I'll give you an example. In the long time ago, I was building analog synthesizers. So we're talking about the 70s and 80s. And I looked up a circuit for doing a crossfade. And basically what they did is you had two audio inputs and you had a couple of op amps, and you took the gain on one down as you took the gain up on the other. But you could do that in a sinusoidal fashion so that you had a nice crossfade. But as I thought about it, every op amp you add into the data stream adds noise. And so I thought about it for a while, and I thought, what if what I did was I'll just use one op amp, but I'll mix an inversion of one of the signals so that the inverted signal will cancel out the uninverted signal. And then I can do it with just one op amp. And so I actually did that. I've got a little synthesizer here beside me, well, buried down in there, that has the circuit that does that very thing. And then I thought, well, this works so well, and it seems to, why doesn't anybody else do this? And so I did a little literature search, and I convinced myself that the reason nobody else had done it was because I must be introducing some kind of phase shift, and that would show up if I had the time and the tools to do a Fourier analysis, that I would see some kind of phase shift. But as the years went by, it turned out that I was wrong. The reason nobody else had done it is because nobody else had thought of it. And a few years later, I saw a guy publish that very idea and document it and claim it as his own. So yes, I have been through that before. Even to the point of convincing myself that, well, if I thought of it, it can't be that unique an idea.
Mm-hmm. Yeah, I think the uniqueness is key there. I had, I guess, one of those moments at Dallas Semiconductor. The in telecom circuits, there's kind of the longer your lines get, the more jitter you get, and it's one of those things that you have to eliminate. And there was kind of a race at the time to put that into integrated circuit form, and there were, and I'd heard about an idea of trying to do it, and actually did it, and it got incorporated into one of Dallas Semi's integrated circuits, and shortly after that I got laid off. So
That'll teach you.
What's that?
That'll teach you a lesson.
Yeah. So, but I think probably it's more the exception than the rule. You may think you have an original idea, and then you look online and it's like, no, not original at all.
Exactly right.
So,
Hey, Murray, welcome. Welcome to tomorrow. We've okay, you're on mute, but we've just finished the humans versus robots part of things, I guess, unless people still want to talk more about that. And we can, shall we move on to the phase 2 part? Are there any show and tell, open webcam kind of things for discussing today?
I would like to try an experiment. I've shot some video, but it's over on my other computer. So the experiment I'd like to try is I'd like to point this camera at that computer screen and see if you guys can see anything.
Sure.
Can I do that? All right. I gotta unplug some cables here.
lots of aliasing maybe between. scan rates or something.
I'm still in my pajamas.
Oh boy.
I just woke up, looked at my email, and went, "Oh, I forgot."
It sounds like the one expert they interviewed last week, and the guy was doing an interview. He had a nice jacket on top, but no pants.
I got pants. I promise.
I'm not looking.
Okay, I can't actually see this now. So can you guys see my screen?
Yeah,
Yeah.
yeah, it works reasonably well.
Okay, let me try to show it. How about
Now, you
that?
might want to change the angle a little bit. Sure, there's your robot.
Cool.
Okay, I can't see it. So does the angle need to go up or down or what?
The
Slightly
webcam needs
down.
to point down.
Like this?
That's
Yes,
it.
that's perfect. Hold it there.
Okay. So and can you see these little LEDs?
Yep.
No,
No.
Yep.
A red one and a blue one.
I can see them from
Okay.
New Zealand.
All right. Well, so I'd like to try to explain what's going on here. This is my office. I had to go into work yesterday, first time in 7 weeks, and nobody was there except one janitor lady showed up. So this is the thing I've been working on. I talked about at the meeting last week, or the RBNO, about having the robot do odometry and try to correct that odometry by having a handy fiducial square, because there's corners everywhere in most indoor buildings. So here, if you can see, I've made myself a corner using my door and a couple of pieces of cardboard taped to the end of this desk here. And so what the robot is going to do is, when I first initialize it, it's going to, I told it this fiducial point, I told it where it is. So it's going to try to square up on these two surfaces and get measure the distance to them and record that. And then it's going to just do a wall following around the office. And I think I set the timer yesterday for 3 minutes. So just for whatever task it was involved in, at the end of 3 minutes, the timer goes off, and this higher level behavior takes over and navigates back here, tries to get back to the starting point, and once again measure the distance between the two walls, and use that not only to correct its location, but to correct the drift in the gyroscope. Or at least that's the idea. So I'm going to run the video if you guys can see this.
Can you go into presentation mode, Dave? Would it fill the screen?
Say again?
Can you go into presentation mode?
Well, it's not on that computer.
Oh,
It's on a different computer.
But you can't pin him.
I'm sorry?
You can pin David and he'll go to full screen.
right. You Ray. So Ray,
okay.
if you look at Dave Anderson's screen,
Yep.
there's a push pin.
Gotcha.
Did that take care of it?
Yeah. Just made the
You
image.
should see my hand there. Okay. So I guess what I'll do is narrate what's going on, and I'll probably pause it. So the algorithm I have working to square up with a surface has gotten pretty sophisticated, and it's a 3-step algorithm. The first thing the robot does is it scans across the surface with its sonar, and these are the sonar here for those of you not familiar with this robot, and they're angled off 15 degrees, or actually 10 degrees on this robot from center, so they slightly overlap in the middle. And so what it's doing is it's going to rotate along, looking for a measurement where they're both exactly the same distance. This sonar returns values to 1/10 of an inch. So when it finds a place where it can point at the surface and both of them are the same distance, that was the algorithm I was using back in the before time. And it turns out that algorithm had some weaknesses to it. So once it finds that point, then the next thing it does is it tries to scan back and forth 3 degrees Actually, I think it's 5 degrees, left and right. And basically, it's looking to see that the surface is actually flat and that the robot is really normal to that flat surface. So I can give you an example. If the robot was pointed into a corner, you could get the two sonars to return the same distance. But obviously, it's not flat and you're not normal to a flat surface. So, okay, so that's the first step, and I'll just press go here. And so there I started the calibration, and it's scanning along the wall, and it says, okay, there the two are equal, so I scan back and forth, but it wasn't flat, or it wasn't normal. So I'm going to keep looking and try again. I'll scan in from the other direction, and it says, right there, they're equal. Can I go left and right, and am I normal to that surface? Yes, I am. So now turn 90 degrees and do the same thing with this surface. It scans left and right, and it says, okay, that one is also, I'm also normal to it. So now it knows from that point what the distance to those two surfaces are. So now it's just going to, it could be doing anything here arbitrarily. It could be doing any tasks. So the task I gave it to do was to follow the perimeter of the office. You can see there that I had to add a box to keep it from going around back behind the table where the little robots shouldn't go. There's just too many cables and delicate things to get in trouble with.
I had to do this with rabbits when I lived in England.
So here it's a wall following algorithm. I think I described recently in one of my posts that basically, if you look over the wheels, you'll see that there are two sharp distance detectors looking left and right. I'm trying to point to them with my mouse. And then the robot has the two forward-looking sonar, and under the front bumper, maybe we'll get a look under it when it turns. Yes, under the front bumper there are left and right IR detectors. So, and then of course the bumper itself is instrumented if I happen to run into anything.
Hey, David, I take it they're all analog sensors?
The sharp, yes, the sharp are.
Yeah.
The ones in the front bumper are just proximity sensors. So is there some, and they can see out to about 10 inches. So
okay, so those are the digital ones.
Well, these are actually some kind of homebrew things, but it's the equivalent. There's one sensor and there's two IR LEDs, left and right. So I actually get 4 ranges. So let's see, are we closing on 3 minutes? When 3 minutes happens, this little red LED right here on top will begin flashing. There it is, it's going off. And at that point, it turns around and tries to navigate straight back to where it thinks it started. And you can see we drifted a little bit. This carpet causes an interesting drift. Okay, so now it says, can I square up and am I normal to this surface? And it said, no, I couldn't find it. That's too far. Let's try scanning in from this side. There it is. Scan left and right. Is it flat and am I normal? Yes. I try the same thing here. Is that flat and am I normal? Yes. Okay, this time, the second time it runs, it's going to follow the left-hand wall instead of the right-hand wall. Interestingly, the errors are different. And I've determined that basically it's the nape and the carpet in my office causes the robot to drift. And so if most of the turns are to the left, it will drift one way. If most of the turns are to the right, it will drift the other way. And that's one of the things I'm correcting for. So when it did those measurements, it compared them to the original measurements that it made, and based on that, it corrected its position. And if it's far enough off, it will also recalibrate the gyro, which basically just means sitting still for 5 seconds and sampling what does still mean.
Huh.
You should come here and look at this. It's pretty cool.
Pretty wild.
Is that a Stephen Colbert, meanwhile? Meanwhile.
I'll tell you those chair legs and the table legs that stick out like that are hard to see and hard to avoid. You can set up the sonar that just says, well, just don't get close to anything. Stay away from everything. And if you do that, it works. It doesn't run into things, but the robot just kind of huddles around out in the middle of the room. It won't go close to anything. So that's kind of basically a trade-off between how close do you want it to go to things versus how, like those legs sticking out right there, really easy to hit. Matter of fact, everything's pretty easy to hit. And I think I do hit something here in a minute. Okay, now, at this point, the only person in the building besides me is a janitor. Oh, you can see the red light flashed and it came. And that janitor's getting ready to open the door and I'm going to chase her away. No, leave. Okay. All right, so we squared up on that wall. And squared up on that one. And as I say, it's I don't know what, after the first two traverses of the room, then I just have a random number generator. So it just, whether it goes left or right is randomly determined. So this time it went right again. So, and I guess this is probably getting pretty tedious. I was having fun. This is my new GoPro camera. There we go. I hit something. As a matter of fact, I'm going to back up. Can I back up? Yes. One of the new behaviors I added to this robot last year was that whenever you collide with something, it drops to a really low speed because the guess is pretty certain if you hit with something, it's because you didn't see it. And so there might be other things you don't see. So bam, and you can see it slows way down and takes a while verifying it sped back up again, convinced that it had a free rein. But it keeps it from banking around against things. It just dropped to about a tenth speed if you bump into something, and then hold that speed for a while until you haven't hit anything for a while.
Huh.
So, well, I know you guys now have seen my robot wander my office 3 times. This is probably getting a little tedious. So, but
Hey, Dave,
I think
how do you do odometry in that? Because I can see kind of a, move in a straight line and then rotate it, stop, rotate an angle, and then move a certain distance again. But you're not.
The odometry runs it, so it's calculating its position every 50 milliseconds.
Oh, okay.
So it's not like driving from one point to another. We talked about this before. A lot of people use the word odometry to mean a style of navigation, and it's not. Odometry is a simple style of measurement. The way you use that measurement to navigate, there's a lot of different ways to do it. Most people think of it as drive in a straight line for 12 inches, then turn left 45 degrees, then drive in a straight line for 15 inches. That's not the odometry I'm using. All I'm doing with the odometry is tracking the position. So when the little red light does go off, it knows how to get back. There, the red light went off. See, it turned right back to go. Oh, look, we're pretty far off this time. Plus, no janitor. And if you look, it looks like this guy should be seeing across the edge, but I think there's just enough for it to see. So there. Okay, he's down now.
Wide enough cone on the sensor, huh?
I'm sorry, I couldn't quite hear that.
Well, you get a wide enough cone on the sonar sensor, enough.
And they do slightly overlap in the center once you get out about 12 inches.
Yeah.
Okay, well, I think I've demonstrated that. There's some other behaviors, especially when it gets off, when the odometry gets way off, it's real smart about getting back on. But unfortunately, it's not getting way off here. I have, however, run this. Right here, I'm just doing it every 3 minutes because I didn't want to make the demo take forever. But I've run it to do it every 5 minutes and every 10 minutes. And I have done it in my office, and sometimes I open the office door so it can go out and run around in the hallway. And I have done it for hours, literally hours. without ever getting more than maybe 8 or 10 inches away from the original starting point. So, and I guess a good question to ask would be, well, if I didn't have the correction turned on, how long could it run? Oh, another hit.
So, David, I think amongst your web pages, you've somewhere published the basic algorithm of this, because I've been trying to find, like, I think that Ray was even maybe asking the same question, is that I'm really keen to try to figure out what that algorithm is and then port that over into Python.
This is the algorithm for the odometry?
Yeah.
It's really not difficult, and I have published it there, but basically what you're doing is 20 times a second, I'm accumulating, 20 times a second, I'm measuring how many encoder ticks have elapsed for the left and the right wheel. And then the distance traveled is those two divided by 2. And the angle that it's gone through is those 2 divided by the wheelbase. And I think maybe this is the last one. I was looking for one where it got off far enough you could see some of the other behaviors.
But in terms of,
I can send you that one.
okay, cool. But I mean, in terms of like being able to, after a period of time, have the robot go back, what you're the bigger algorithm is, after you've done all this measurement, you know basically that the robot is a certain distance from that starting point in X and Y terms, and then you just go back to that point?
Yes. I see. Are you asking about the navigation algorithm rather than about the odometry algorithm?
Yeah, I think so. Yeah, basically how to get back to that starting point.
The navigation algorithm depends on the fact that this robot runs subsumption. And the best way I can describe it is to think about how a photovore behavior works on a robot, because that's one a lot of us have done. So in a photovore behavior, basically what the robot does is it has a couple of cadmium sulfide cells or something like that, and it measures multiple times a second whether it's brighter to the left side of the robot or the right side of the robot. And then it issues a command to turn. This is a very low level in the hierarchy. So it issues a command to turn in the direction of the brighter side. And that's all. That's all it does. So when you combine that with avoidance behaviors like bumper and IR and sonar, which are higher priority, what the robot does is it will navigate toward a bright light, with the higher priority behaviors pushing it away from intervening obstacles. And when they're not running, the lower priority photovore behavior pulls it toward the bright light. In the case of navigation, you do exactly the same thing. So 20 times a second, you calculate, is the waypoint I want to go toward to the left or the right at the center line of the robot? And if it's to the right, you turn right, and if it's to the left, you turn left. That is only for a 20th of, for 50 milliseconds, only for a 20th of the second until the next time through that loop. And so by the same token, you can think of the waypoint as pulls the robot toward it, where higher level behaviors pushes away from intervening obstacles. There's the red light flashing. You'll see it going toward the waypoint, but then it had to be pushed away to not run into that UPS there. And now it navigates. And this is Shirley's last one, because I got really carried carrying my camera.
But Dave, somehow you must aggregate each of these 50 millisecond distances, right? So somehow the robot has to have it seems like it has to have a state estimation of how many ticks and in which direction is the waypoint or their origin from its current position. Okay, well, when I hit reset on the robot, it set the X location and the Y location and the theta, the rotation, to 0. So when it comes out of reset, those are all 0. Let me move my laptop back. Am I back?
You're back.
Yep.
All right, hang on a second. So that actually worked.
Yeah, well done.
All right, I'll back up again.
Oh, at some point, I've had to just be distracted. Will and I worked on position estimation of a robot, really in the soccer course. Whoops, am I being heard?
Can hear you. Yep.
Oh, okay, great. Anyway, let me see if anyway, so kind of an interesting exercise. I guess I worked on it some, but Will is the architect, really, of taking a robot that sweeps a LiDAR sampling out and, analyzing its data within this rectangular course, and almost in a more or less, you can place the robot in the course and then it's able to determine where it is. And anyway, I can, let's see if I could share that, or if I interrupted, let me know.
Well, let me just finish my description, and then I'd like to see what you're working on.
Okay,
Cool.
okay, sure.
So I'm just going to do this by waving my hands. So the robot comes out of reset with its position X, Y, and Z as set as 0. So basically, whichever direction it's pointing, arbitrarily, when you push the reset button, is 0. X is left and right with positive X to the right, and Y is forward and backward with positive Y in front of you. And just out of convenience, I do all this on a 1-inch grid, although, or I should say a 10th-inch grid. So, for example, point 10 feet ahead of you would be Y at 120, X at 0, and Z at 0. Point 10 feet to the right of you would be X at 120, Y at 0, and Z at 90 degrees, although Z is actually calculated in radians. So when I set the thing off running, I'm updating X, Y, and Z 20 times a second. And just wherever it wanders around arbitrarily, I'm not telling it where to go, but wherever it does go, it's 20 times a second. It updates X, Y, and Z. So yes, it's accumulating the positions of X, Y, and Z. And I can put that algorithm. I'll send it to the DPRG list. So that's the way the odometry runs, and the way it calculates an updated position. And that's the one that position is what drifts over time. And with a whole lot of analysis, it turns out that what actually drifts over time is not the distance traveled, but the theta. It's not X and Y that are drifting, but when theta drifts, X and Y get off. So the thing to do to correct the drifting of the odometry, step 1 is, rather than using the difference between the wheels divided by the wheelbase to determine the direction that it's pointed, to substitute a gyroscope. And of course, gyroscope also drifts. And probably somebody sufficiently versed in Kalman filters could combine the two and maybe improve both. But the drift that you have to correct for over the long term is not the drift in how much, it's not slippage of the wheels. It's not how far you've traveled. It's the direction that the robot is pointing. And that's really the piece that I'm correcting when I go over and square up in that corner. I correct it by getting normal to the wall. And once I get normal to the wall, I now can correct the drift in theta. And then I also correct the drift in X and Y as long as I'm there. That, and to Murray's question, so that's running all the time. That's just a sensor. It's a virtual sensor. So X, Y, and Z are updated 20 times a second. And then what you do with those is fairly arbitrary, and there are a bunch of different things I do with them. For example, one of the behaviors I have, you can define a box that's an offset from the starting point, and you just have a real simple behavior that looks a whole lot like an avoidance behavior that's just testing 2 points that are out in front of the robot to see if they have crossed the boundary of that box, and if they have, you turn away from the boundary. So the result is that it'll just stay inside an arbitrary box. When I said I let the robot out, run around in the hall, I actually have a box that goes about 30 feet each way down the hall so that the robot doesn't run away, and especially so that it doesn't go through into the stairwell and fall down the stairs. That was an algorithm that had to be added. It was required to be added. But that's one that really doesn't have anything to do with navigation, but it's basically you have this invisible box that the robot was, like a geoboundary, that the robot will stay inside of. And the behavior is exactly like the sonar or the IR behavior, which is just if one of these virtual sensors crosses that virtual line, you turn away from the line. And that way it'll stay inside the box.
So
the navigation.
So this discussion we've been having about like B&O 55s and stuff like that, if you were to be able to combine an ongoing compass heading sensor with the theta that you're measuring, you could basically, on each basic 20 millisecond measurement, you could correct on a 20 millisecond basis what you think the compass heading is with an actual compass heading.
Well, now that's actually what I'm doing now. The odometry in its purest form derives the theta, the heading, from the difference between the two wheels. I run exactly that same algorithm, but when it gets to the point where you're trying to calculate the x and y position, x is basically the sine of theta times the distance, and y is the cosine of theta times the distance. So for theta, I use the gyroscope instead of using the one measured from the wheels. And it does work better on some surfaces. I have a place at SMU where there's this gorgeous marble floor that's just flat and smooth, and on that surface, the regular old school odometry works better than the gyroscope. But in my office, where the carpet forces a drift, the odometry gets off, but the gyroscope does not. Same thing when I go out, I run that robot out in the parking lot sometimes and around back in the loading dock where it's asphalt and gravel, and the regular odometry is miserable in that environment, but the gyroscope odometry works quite well. Also, the gyroscope allows you to do some cool things, like you can pick the robot up and rotate it 90 degrees when it's headed toward the target, and it'll turn around and head back toward the target. It knows it. I also use that. There's an interesting error condition that arrives since I'm running the wheel odometry all the time, whether I use it or not. If you compare how much the wheels say the robot has turned versus what the gyroscope says the robot had turned, even though they drift apart over time, for any given time sample, they're pretty close together. So if they're not close together, your wheels are slipping, or you've been jammed up against them. If, for example, you grab the robot and hold it so that it can't turn, the wheels might say, I'm turning, because they're slipping, but the gyroscope will say, no, you're not. And so when I see a large difference between the wheel rotations and the gyroscope rotations, I flag that as an error, and I try to do an escape behavior.
Yeah, cool. Thank you, David.
So, David,
Ron? Oh, I'm sorry, Ray.
Hey, so I'm assuming you're doing everything in like, doubles, right? Because you'd have a lot of accumulated error if you didn't.
That's exactly right.
Yeah. Okay. Wow.
You've just revealed you've pulled back the curtain. We've seen the magic.
And it turns out, like with all magic tricks, it's pretty trivial once you know how it's done. Ron, I think you're up.
Yep.
Okay, sorry for interrupting. I had my headset off, and I guess I just tried to sample about 5 seconds of what David was saying. I think, it's a good place to jump in. It was a bad place. But, okay, let me see if I can, let's see, which screen am I going to, I can select the window. Okay, let's see if I get the right one.
While he's talking, can you hear me?
Yeah.
Let me explain what I'm trying to do here is, since odometry eventually drifts off, what I want to try to do was, can you locate yourself inside the course by using a LiDAR and use as much as data as you could get with the LiDAR, and use, so you use not just one or two measurements, but every measurement contributed to solving the problem. And it doesn't particularly matter which portions of the course you see, if it can see enough to determine its location, it should be able to locate itself. So this is a simulation that Ron and I worked on about or so ago. The red is the course as the robot sees it right now, I believe.
Yeah, let's move around. Let's see. So the actual position of the robot, you can see the where the arrow is. Can people see that? I guess I can't see what you're seeing.
Green and blue. Yeah.
The green.
Yeah.
The blue. Yeah. The blue is where the actual course is, and the red is where the robot thinks the course is, and the green is the difference between where the robot thinks the course is and the position the course is actually. And so basically what the robot's trying to do is reduce the area, that is the total sum of all those green lines.
Oh, and also just to note that the initial assumption is that the robot is going to think that it's at the center of the course. So it's going to be its initial, that's where I think I am. So hence, it looks pretty good if we actually put the robot in the center of the course. Does that sound pretty good, Will, as far as?
Yeah.
Okay, so that's our initial, so we could really have an initial guess of anywhere. But we thought, well, at least that would be one initial guess, and it might be fairly bad, because if I move the physical robot over to the corner, it's terrible. You can see it's where it thinks it is, there's a huge error, which is, yeah, so you're seeing that. And okay, so let's try something. So what we'll do is we'll move the robot just slightly ahead of center, and then I'll ask it to iterate and solve. Go ahead, Will, as far as the iteration process.
We iterate to try to reduce the total area of those green lines to 0, as close as we can get it.
And it's done in 3 steps, as I recall. I can't remember, was it Y, X, and theta, Will?
Yes.
Anyway, the steps are repeated successively. And I think, I don't know if I can do it manually, but I can automatically tell it to iterate. So I'll go ahead and do that now. So, okay, so we'll move the robot ahead of center, and let's see if it can find where it really is. Okay, here we go. Bang. Okay, it did it in a couple of iterations. So, in other words, and part of this is the fact that, well, we could be, let's say, off one direction or another, and it's going to solve fairly well. Whoops, it took an extra couple of iterations. So in other words, what it's proved up here is that the robot has physically been able to determine where it is, and that agrees. We see the agreement, yeah, between the red and the blue, there's nothing, no error. Okay, and another case would be is if we were, let's see, fairly close to center, but we'll rotate the robot. So we'll give it about a 45-degree angle. Let's see if it can solve that. Yeah, so it was able to solve that. But there are cases where it's not able to solve. So even after, so it's given up there. So in other words, but that was a case where our assumption was we were at the center, at the center of the course, facing the goal. And obviously that's a terrible initial estimate of where we are. And in this case, I actually did produce an analysis, let's see, of the positions to show if it was able to converge. Whoops, I think I did. Oh, here, it's actually doing it right now. Okay, so it's now iteratively testing a number of different starting positions and seeing if it converges. And if it does, it knows it does, because again, we see the green lines, and it knows if it gets it right, it's got it right. And certainly there could be other methods to try to achieve this iterative solution. Particularly if it found it couldn't converge, it could make some guesses about its orientation with the current algorithm. But anyway, when we get through this, we'll be able to look at the analysis to see where it wasn't stable. And it'll take probably another minute or two. Any questions, or Will can add more?
So you're saying the assumption that you're close to the center of the course and pointing forward if you're not?
Correct. Correct. Yeah, so the idea was you could plop the robot down and not have to tell it anything, and it would be able to determine where it is.
Where it was. Huh.
Yeah.
Why do you think that is, though? Is it just that that's a strange one?
What do you mean?
Why it's not able to determine its position?
Yeah.
Well, it does have to do with the fact, yeah, the initial condition or the initial assumption in that case was poor, and there might be a way to generate a better estimate of where you are. But I guess it doesn't. The algorithm doesn't require that you have a good estimate of where you are, but it does at this current time. It can fail. And here I'll show the. So here's not very good. It's just sort of a poor kind of. But you can see it's odd that it was able to converge except one side of the course and near two of the corners. I don't know if that's a very good graph, but it's something I just kind of hacked together at some point. And this is months and months ago, so it's kind of gone a little cold here.
So are you hitting a local minimum? And
yes,
what's your hypothesis generator look like for like the next thing to test?
Well, go ahead,
Will.
Will.
Repeat the question again. Can you hear me?
So when you fail to converge, it kind of looks like you're hitting a local minimum and not figuring your way out of it.
Right.
That's correct.
And that's got to be partially due to the how you iterate to the next step is probably based on like some degree of rotation, like fragmentary degree of rotation or translation. And you're probably not taking, bigger steps, and somehow the next one that you're calculating is tending to put you back into that well. It's looking like worse error. So can you describe what your hypothesis algorithm is for generating the next iteration you want to test?
All right. It's a rather crude optimization program, far from optimal. Basically what it does is it tests, it calculates the value, and it moves the robot 10 inches one direction and then 10 inches in the other direction, and decides which direction it needs to move is better. And then once it decides which direction is the best way to go, it steps in steps of 10 inches until it overshoots. And then it stops, and that's in Y direction. And then it does it in the X direction. It basically steps in one direction, steps in the other direction, finds out which is the best direction, then heads off in that direction, taking 10-inch steps until it overshoots. Then it does the same thing in the angle. It rotates one direction, I don't remember the number, 10 degrees, the other direction 10 degrees, then decides which is the best direction and rotates around till it overshoots. Then once it's through that cycle, it reduces step size down to, I think we cut it in half, and then it goes through that cycle again, and it does that a fixed number of times. So it's a very, very poor optimization algorithm, but it was easy to come up with.
Hmm.
Does that make sense?
Yeah.
That makes sense. Yep.
So this is your data is it's all simulated, right? You're not actually using a LiDAR and picking values off, right?
Correct.
We actually used some actual LiDAR data,
Oh, you did.
and it actually located where the robot was located in the course.
Oh, you did. Okay. Yeah, because the LiDAR that I used, I tried to like do straight line approximation, and depending on how close the LiDAR is to a wall, if you get a very shallow angle, kind of like what you're showing, the dots got further apart. In my case, I didn't get any dots at all in a row. It was just a big blank spot. So, and there was even the dots in the row. They weren't really close to a straight line. There was a very fat line. It wasn't a very thin line.
Yeah.
When you
Oh, go ahead.
try to figure out if they were points on a line or not, or which points were on which line. So. Yeah,
actually, I've kind of forgotten. So I guess I carried this simulation over to the real robot. Maybe whatever, next time we'll see that. But I'm pretty sure, isn't that correct, Will? I've got to remember. I think I went ahead and set up a course and got pretty good results. I think the results pretty much were compatible with the simulation.
Well, we did, we set up the course and actually measured the data, and then took that data and used it as input, and then saw whether the robot could find itself. And incidentally, the original course was not perfectly rectangular. It had some offsets in it a little bit, and so it basically tried to line itself up with the closest approximation to electric. We had another video, another simulation that showed that, but basically the robot has to know how big the course is. It has to have I guess you'd want to call it an internal model. Dave, you can hold your hands over your ears when I say that. But basically it knows basically what the course looks like, and then from it basically has to calculate then what it thinks the data should look like, and it compares the data that we actually get to the data that it would get if it was actually at where it thinks it is. And that's the green lines. And so it's trying to minimize that. And one of the problems we have is particularly when the robot is misoriented, the problem is a ray will, let's see if you can see it. This red, you see some red lines out beyond the course. Those are where it thinks that's the wall out there, and you got to somehow eliminate those false lines out there. There's another demonstration that we have, I think, that shows this better, but that shows that it shows the demonstrations, the iterations one by one. It doesn't seem to get as fast a solution as what we've shown here.
So you're talking when the like the points beyond the boundary, it's actually getting readings off of like a wall in behind the course through the goal.
Yes.
Yeah.
And the problem is, see, that gives you some false information.
Yeah.
And as the solution converges, it eliminates that false information. But it initially starts out and doesn't know whether the whether it's actually looking at the wall or whether it's looking at the actual course.
Yeah.
And hopefully gets rid of it.
Yeah. It's kind of weird. I'm not quite certain how that happened, but the Can soccer course, I think the boards are getting warped a little bit because we don't store them on a flat surface or anything. So wherever they get thrown, they they get a little twist out of it. Anyway, the floor in that room is not flat. So Doug had joined basically cut the 2 10-foot lengths in half, and there was a gap on the top of that joint, and it seemed like, well, I was looking for kind of a big jump in distances or change in differences, and that would indicate the corners of the goal, like between 2 readings. If there was a big jump, that's what I was looking for, and it would find that gap in the center of the long wall where they didn't quite line up because they weren't flat on the floor. And it would think, there's one corner of the goal, and so it would take that corner and then the next corner and run into the wall, basically. So,
well, Ron,
this one doesn't have that problem. In fact, the LiDAR sees the wheels on the robot, so it has a couple of blind spots, and we have to take that into consideration as well. So it does the best it can to line up the ideal course with the actual course, and so it can't reduce the error to 0 if the course is not perfect, but it juggles the ideal course to be a best fit on the actual course.
What do the rules say about allowing a self-calibration period with just one robot on the course?
I don't think there's any rule on that.
of course, Doug is the rule meister. You'd have to ask him. So,
Please, Doug, please.
please.
Well, I hope
Ron?
you find it interesting.
Yeah.
Ron, can you bring your display back up?
Sure. I was going to try to, but I don't feel alive enough to make it single step. I could probably figure it out in slightly more time, and you'd want me to sit here.
Ron, try another sketch. We've got another sketch that's much better.
Well, I've written probably 50 or 100 sketches in the last so many months, so I think I might have these tucked away somewhere. Unfortunately, I'm going to have to do some looking.
That was enough for me to ask my question.
Oh, okay, let's bring it up. Okay, hang on, let's do that. Okay, shoot.
Okay, as I understand your description in Will's, the red points here represent information that the robot already has when it starts. That's correct?
Let's hang on. Let's check that. That's correct, because look, as I move the robot around, the blue is what the robot will perceive or will measure, right? Okay. In other words, if I move the robot to the right, then physically the blue is what its sensor is going to pick up. Red is its model, and the cat. It sounds like a cat too. Is that part of this simulation?
That was my question. So the red dots represent data, information, what Will called an internal model. that the robot already had before this process began.
Right. And that right now that's
Basically,
fixed.
I haven't gotten to my question yet.
Okay, sorry.
So basically, the difference between the technique you're describing here that you guys have working and SLAM is that the red dots in SLAM would be determined on the fly by the robot itself. Is that correct? You're familiar with
I believe that would be correct. In other words, if you set something down in a room, it has no internal model initially.
and so it has to, by wandering around, it makes its internal model, and then it keeps track of its location by comparing and updating that model against what it thinks the measurements should be.
That sounds pretty good.
Basically the same thing you guys are doing. It also has the, I think a good bet, if you're just running this in the robot course, which is a really pristine environment compared to the real world, a good bet is that you're not going to drift off very much. You won't be, you're not going to be way against the wall when you think you're in the center. So those cases, those edge cases, you're probably with a real robot, you're never going to encounter.
Right. I guess the only case there would be is if that was an initial position currently with our relatively simplistic idea that, hey, we're just going to pretend we're starting in the middle, facing the goal. And obviously you'd be able to determine that, hey, I'm probably in a corner because I'm seeing data points that are 3 inches from me. I'm not in the center of the course. So there's probably some very simplistic things that could be done that says, okay, if I take the robot and stick it over here in the corner initially, obviously we know that, well, we can see there's a great disagreement between the internal model, which is based on the assumption that it's starting in the middle of the course. So that's why there's such a disagreement there, of course.
My second question is likened to it then, which is that can the robot, as you currently envision it, can it run this process continuously when it's in motion?
That's a little difficult. The thought was that really odometry is good enough that my thought would be, why not run the process when it comes to a stop? Let's say it drives to a can, for example. It's a great time to run the process and then compare, that against the odometry and correct the odometry.
So it's basically doing something similar to the video I showed earlier, which is from time to time using this process to correct its odometry position and rotation.
Right, and that's what prompted Will. Hey, Ron, dig up that, dig up the simulation.
Well, the answer to your question is, right now, I don't know exactly how long it takes this algorithm to run, but it's not, it's not instantaneously. There's,
well, we're seeing it right now.
I think there's 360, basically the LiDAR puts out 360 data points, and so basically we have to compare, compute each one of those errors, and you do that then for each iteration, each step of the optimization. So it has to do, I don't know, it's probably in the thousands of steps. So it's not, it takes, I don't know for sure, but I have a feeling it'll take us at least a couple hundred milliseconds. I don't know how fast the computers are running, but it would be my goal to answer is I think we can almost do it on the fly, and not only do we
go ahead.
Basically not only incorporate the fact that to incorporate at least odometry in it, so that between iterations it knows it has moved, and basically that's what SLAM has to do.
So maybe an M4 core with floating point. Well, I guess that's floating point with it, right?
Yeah. Right now, of course, what you're seeing it run on is a fast Intel, not that fast, but an Intel i7.
Yeah.
So obviously it can solve it in a matter of, and here I'm doing fewer iterations just for fun. I don't know if this is legible at all, but I cut my iteration count from 8 to 3, and you can see it's able to solve pretty fast.
Pretty quickly, yeah. Do you also look at out of the LiDAR, like the ones that James Leroy sold out of the NITOs? It give you kind of a confidence indicator about each reading. Do you look at those and throw out the bad ones? Because you will get bad ones.
Well, so far the data's looked reasonably good, other than coarse warpage, which shows up. But I guess I'm mainly been running in a styrofoam course that's similar. It's only 6x8. It's a little different dimensions than the full size course, just because I couldn't fit it in my office.
Need a bigger office.
Well, the algorithm itself tends to throw out bad data. Particularly as it has at least the potential as the solution gets better and better, any outliers can be discarded. In fact,
I think that's what's happening here, isn't it, Will?
Well, yeah, you notice that there's some red dots out there, which basically says this is what the robot thinks it to be seeing. But you notice there's no green lines to it. And one of the things that only rays that it thinks are hitting the model are used. Any that it thinks are going through the goal are discarded, and it's part of the algorithm. It discards any that thinks it's going through the model. So it only looks at what it thinks walls. And of course, if the walls and if the actual course and the actual and the model are not aligned, there's some rays that don't cross both the model and the actual part or actual course, and so those eventually get thrown out.
Oops, I was seeing if I could get the single step to work, but something's going on here. I'm not sure.
Yeah, I think one of the things that Doug and I tried to look at were, well, we actually tried to find the corners, the 4 corners, and basically estimate position based on that, knowing that the 2 long walls are 7 feet apart and the 2 short walls or the 4 short walls are 10 feet apart. And so yeah, and I think that's what Jack was trying to do too with his his ring of LEDs around the thing, just to try to indicate, okay, this is the short wall point. Perpendicular point to the short wall. Yeah, I think if I'm not mistaken, I think that's what Scott does too.
I stopped presenting. Get rid of me.
Yeah, I think we're through.
That's cool. Very nice. Thank you. All right. So anyone else have something to show? All right. Well,
I have a comment.
Cool. What's that?
I have a comment to make. Let's see. Is Steve here?
Steve left a little while ago.
Steve left the building. Okay. Well, none of the people that I sent boards to this week. No, Ray's here. Ray. Yeah, there he is. Hey, Ray. This is just a note I was going to make to Ray and Steve and Doug. Steve and Doug are here. Those boards I sent, the pinouts are arranged in a way that are useful for the kind of I/O I want to do. So I actually have a document that describes the pinouts that I'm using, actually the one I'm working on for JBot, and about half of those require in the ARM the alternate function pin, where you actually change the, and I've got a document that roughly describes all that. I thought it might be helpful to send that along with the board. Sure. I'll send those to y'all. That's all.
Very cool. All right.
Kareem, where'd you get that steely-eyed photo of yourself there? That's a
man of mystery photo.
What's that?
That's the International Man of Mystery photo.
That's right.
Yeah. I just posted a note to the list last night before I went to bed. I've been obviously working on lots of different things, but I haven't actually spent much time on my robot operating system because I've been kind of focused on this whole Arduino to Pi communication. And I have these now, which are pretty amazing. Ooh. It's actually a micrometer gear motor with an encoder built in, and these little brass hubs onto these nice little mecanum wheels. Unfortunately, and maybe actually fortunately, in the photo for these brass hubs, they show 2. So I ordered 2 items thinking I was getting 4 brass hubs, but I only got 2. So I've got 2 more coming from Canada, which is actually a benefit, which means that I can't work on this other robot. I actually have to go back to my main robot and get my PID controller working and do all that. So this is now on hold, but they're really quite cool. It's amazing. Like, you know, that's actually a full motor control and a mecanum wheel. So I got 4 of these in a design. So I had asked on the list if anybody, I posted a little schematic of the floor plan of the robot's wheels and everything. And I'm kind of curious to know that should those, the center point of the wheel, should those all be on a square or a rectangle? I mean, on the, they're actually a circumference of a circle, of course, but can it be an oval or a circle? Does it matter?
Well, I don't know. Carl, do you know?
They need to be orthogonal to each other, but they don't have to be in a square.
Oh, okay. Because I'm kind of leaning towards a square so that the robot is entirely symmetrical in all directions. Because but it doesn't really matter.
Won't go wrong with a square. It'll also,
all right.
Just make sure that you have about the same amount of weight over each wheel.
I noted that in my
balance more so
that's
than
what I noted.
Robot platform.
Cool, thanks. That's what I kind of surmised in my blog post, was that it was pretty critical on these, that they all are equal. So thank you.
Yeah, mine is a rectangular platform, but it's not far from a square. And that's the part I haven't done yet, where I wanted to calibrate encoder ticks per distance moved and see how it varied on straight front to back or side to side versus diagonal.
Okay.
On different surfaces.
If you go online and Google it, I can't remember where I saw it, but somewhere there is a full-size fork truck that uses those mecanum wheels. And I believe that they're set up so that they look like they're on the edges of the square. And he can, of course, go sideways and forward and backward, and he can rotate and go diagonal and everything. It's pretty cool. I don't know if it actually turned into a real-life manufactured product, but somewhere out there I remember seeing that.
In my blog post, I actually have that link. It's from Turkey.
That very well. Okay.
Yeah. It looks like a real product. It's an electric forklift that does a demo back and forth and all that. Yeah.
Very cool. Very cool.
We're going to get there, Murray. As soon as I can get my donkey cart thing running, then I'll bounce back to the mecanum wheel and see if I can't put that extra layer in that makes it simulate a hovercraft. But yeah, we'll get there.
Well, I should I will mention the one thing I did find, which I didn't make a link to, was there is actually a macadam wheel industrial platform that uses 2 pairs in the, like a pair of wheels in each corner. So it's actually an 8 macadam wheel device. It's only about a foot off the ground, but it must weigh an enormous amount because what they use it for, it's actually got a robotic controller with, I think, infrared or ultrasonic, and this thing basically creeps along a concrete floor and they move it underneath aircraft assembly things. It uses both some kind of a either ultrasonic or infrared guide, and then once it gets close enough, it hits a little bumper thing and aligns itself underneath, and then raises this huge piece of aircraft. Like I think it was, they had a 747 wing or a tail. I mean, lifts that off the ground and then moves around, and it's all macadam. It's pretty cool.
Neat
Our
stuff.
defense dollars at work, I guess. Huh?
Yeah, exactly. Anyway, that's it for me. Thanks.
Cool.
Yeah.
Cool. All right then. Well, yep. Well, another good virtual meeting. I think that's awesome.
Yes, very good.
Awesome. Mr. Anderson, I'm going to send you some page authority links that I just snapshotted, but your page is looking pretty good, basically. So watch your email for that. But all right. Well, until then bid you all, let's have a great weekend. Enjoy this weather here in Dallas. Hopefully, it's good in New Zealand as well. And
It is.
awesome.
So how cold is it up there versus here?
Well, we're heading into winter, but we've had unseasonably warm weather, and so we don't do things in Fahrenheit here, unfortunately.
Right.
So I think we had a high of 18 degrees Celsius yesterday, so that's like in the 60s, I think.
60s. That's
Yeah.
cool.
Yeah, which for late autumn is not bad. We're actually getting quite nice weather. If it's not windy, like Wellington is the windiest city in the world. And so when it blows here, it really blows. Like I get 140 kilometer per hour gusts hit the north side of my house sometimes.
Whoa.
Yeah. Yeah, the house kind of moves a bit. Yeah. That's unusual. We usually 120 is usually as high as it gets, but we've had 140. But
We get
yeah,
that in
it blows water through the wall.
Whoa.
Yeah, I've repaired that now. But when I bought this house, there's no insulation in Kiwi homes. They don't put insulation in the walls normally. Like this is a 1966 house, and when I bought it, it had no insulation, just that black paper. That was it. So my north wall now has got American jib. The woman I bought the house from bought a whole bunch of pieces of American jib from the American Embassy in Wellington, which is imperial measurement, because nowadays you can only buy metric jib, but she got imperial measurement jib, not 10 mil, but 5/8 inches. So she got all this jib. So I did my whole north wall with jib and Australian insulation, and then double glazed the windows so the walls don't have water blowing through them now.
Murray, how cold do you get in the winter?
Not that cold. I've lived here since 2006, and it snowed twice for like a day. So no, we're temperate because of the water around us. We get cold and rainy winters. South Island gets lots of snow, but in the Wellington area and north, up in the mountains, yes, of course, but down at sea level, no.
Yeah, the one time that we went to New Zealand, we went to, it's been so long. I think it's called the Milford Track.
Milford. Yeah, way in the South Island, deep down there.
Right. Anyway, there's a one-way, one-lane tunnel, with lights on either end, and we were waiting at it for it seemed like 20 minutes before, and the light was just stuck. It was red.
Wrong mute.
What's that? Oh, anyway, we thought the light was broken. So we start down the tunnel, and I don't know, 3/4 of the way through the tunnel, a set of bus headlights come pointing at us. We had to back out of the tunnel.
Oh my!
And it was, to add a little more drama to it, it was snowing these big, fluffy flakes of snow. And it's like, oh my God, driving through a tunnel backwards.
Yeah.
Not a fun experience. But.
No, it's the whole South Island. I think only has a few 100,000 people living down there. The North Island's where most people live. South Island's where all the big mountains are, and there's not that many. There's Christchurch and Dunedin are the two big cities, and they're not that big. And the rest of it's pretty sparsely populated. We went down over Christmas along the west coast. We didn't get as far as the Milford Track. Went down to Hokitika, and the towns are all small. And as you note, you come up to these places where on a mountain road, it's washed out or something like that. So they're working on it. So they've turned it into a one lane, and you've got a red light at each end, and you just wait and you wait.
Yeah.
And one time we waited for like 40 minutes. And it was obviously that we were waiting for people because there was cars coming and stuff. But one time we got to the other end of one of those and came out the other end of that, that maybe quarter mile, half mile. And there was a queue of cars that there was no one on the island, right? We thought there was no one. We get to the other side of this queue, and there's this queue that went on for like 5 miles of cars.
Wow.
That's how many people were waiting. There were lots of people.
Sounds like Dallas. Sounds like Dallas.
Yeah, but this is like everyone on the South Island on one road.
Yep. Yeah. Yeah, I like they're one lane bridges that have a rail line going across them. So you not only have to look at, traffic coming in the other direction, you have to look for trains coming from both.
Wow.
So it's kind of like, okay, let's go for it. So,
Carl, are we on for Tuesday?
We're still on for next Tuesday, regular bat time, same bat place.
Okay.
So maybe some of us will have something to show by then.
Tuesday,
Well,
thank you very
much. We can all do the steely-eyed photo, kind of like what Kareem's done here.
Yeah, I'll work on that.
Thank you very much for your presentation, Carl. It's very interesting, very informative. Yeah.
Oh, cool. You're welcome.
Very
No
well.
problem.
Very
And don't stress.
thorough.
Yes. And don't stress too much when you go bike riding today.
Oh, no worries. I'll drop a couple pounds. It'll be good.
No, I think we're supposed to be, 82 today, or?
It looks like it's 74 out there right now.
Okay. I thought they were going to be higher today. Okay.
One of those